Once again, I appreciate you stopping by to check out yet another episode of Vintage Audio Review. In this episode, I'm going to talk about this integrated amplifier, which is a KA4002. In 1971, if you had $140 or about $1,000 today, you could purchase this little integrated amp, which was rated at 18 watts per channel into 8 ohms, both channels driven, at not more than 0.5% THD, with a frequency response of plus or minus 1.5 dB from 20 hertz to 40 kilohertz. Now, this particular unit came to me with a problem. They said the volume in the right channel is very low. So once we do a little tour of it, I'll hook it up to my analyzer and we'll see if we can see where the problem is, whether it's in the preamplifier stage or the power amplifier stage, as I believe this has a separated preamp and power amp hookup. Here is a closer view of the KA4002. Starting over on the left, we have our power button, which is in red, which is kind of nice. Have a 1/4-inch headphone jack here. We have a loudness switch here, a stereo mono switch here, a low filter, high filter there, and we also have our tape monitor switch here. We have our power on lamp here, and we have a 1/4-inch tape dubbing jack over here. Our selector switch has inputs for 2 auxiliaries, 2 phonos, and a tuner. Here is our volume knob here. Our balance control is here, and the balance control has a center detent. Our bass and treble controls have detents all the way around. You can hear that. And then we have our speaker switch there for A, B, or A plus B speakers. As far as physical dimensions, the KA4002 is about 13 inches across by almost 10 inches deep by about almost 5 inches tall. So it's not a very big footprint, and it weighs in at 12.5 pounds. This obviously is the rear of the KA4002, and starting on the upper left, we have our 2 phono inputs. We have a tuner input, and then our 2 auxiliary inputs. Here is our ground lug for the phonos, and here are our main in pre-out jacks, and you use this switch here to have it in the normal mode where they're connected, or if you go to separate, you can use this as either just an amplifier or a preamplifier, and that is how I'm going to be testing to see if the problem is in the preamplifier or the main amplifier. We have our tape monitor circuit here. It also has a DIN jack that could be used. We have a mono out jack, which is kind of neat for the time. And then we have our 2 sets of speaker jacks, and they're kind of knurled little knobs that you would wrap your wire around and tighten down, or you could use spade lugs. They're easy to grip. And then we also have unswitched and a switched AC outlet. Fuse right here, and we do have a voltage selection here that will select between 110 or 220 volts. So that's kind of what's going on in the rear of the KA4002. Here is what the inside of the KA4002 looks like with its cover removed. One thing to point out is this big capacitor right here, this filter capacitor. There is only one of them because this is a single-ended power supply, meaning it only has a plus voltage. Obviously, this is the power supply transformer. These 2 big caps here are what couple the output stage to your speakers, so it's not direct coupled to the output. Basically, it just gives you an idea of how this thing was built. Right now, I've got a signal going into the auxiliary 1 input. I've got the preamp and power amp stages connected together, and we're looking at the output into 8 ohm loads. And as you can tell just from the gain, the right channel's about right, 21 dB. I've got the volume control set to about halfway, and then the left channel gain is minus 15 dB, and you can see the, let me get rid of the right channel. So there is the left channel, it's down there pretty far, and You can see the right channel is up, plus the left channel has a lot more harmonics going on with it. You can see that would be the good one, the right channel. So we've got some issues in the left channel. So right now I'm just going to connect to the power amplifier directly through the main in jacks, and we'll see if the problem is in the power amp stage or the preamp stage. Right now I have the output of my analyzer going into the main in jacks on the Kenwood. I had to reduce the gain a little bit. I think it was around minus 12 dBV, and now it's minus 20 because the amplifier has quite a bit of gain. At least the good channel has about 42 dB of gain, and you can see the left channel is minus 8 dB of gain or so. So once again, your left channel is in yellow, and that is much lower. So we have a problem with the amplifier. On the bright side of things, we have a real low, 0.01% THD. Of course, we don't have much power coming out. After several hours of troubleshooting, I'm embarrassed to say, I was able to get the left channel to be very close to the right channel. You can see that both of them are about 5 watts into 8 ohms. And that is with a very small signal, minus 26 dBV going in, because our gain is around 42 dB of just the power amplifier stage. So right now they look really good. The right channel has almost 10 dB worse in SNR than the left channel, maybe because of some of these power supply hums. There's one right here, another one right here, where the left channel is much lower than the right channel. So there's a couple capacitors that I'm going to replace on each channel and see if that improves this. But right now I'm going to go ahead and show you what was the problem that caused the low gain for the left channel. What we are looking at is a section of the main amplifier schematic, and the left input comes in over here and the right input is here. The nice thing with having the right channel working is that you can measure the voltages along the way, as well as some of the waveforms, and then compare the two. Now, I don't know how I missed something like looking at base emitter junctions and collector to emitter junctions and all that, but I kind of didn't do real well with the troubleshooting until I actually made a big copy of the schematic and started writing down the voltages along the way. And once I did that, I noticed that around this guy right here, which is QE13, it was reading about 1.7 volts here at the emitter and about 30.1 volts at the base. Obviously, that should be 6/7 of a volt drop there, and it wasn't. So this guy turned out to be open, and once I replaced him, the amplifier worked just fine, at least the power amp section. Now, this was replaced with a 2N2221A transistor. It's a metal case transistor, basically an ECG or NT123A equivalent. So I replaced that, and then it worked. And you saw the THD SNR plot just a little bit before I showed you the schematic. What I'm going to do is replace 2 capacitors, one capacitor on each side, and that would be this 47 microfarad 50 volt here. It comes off of the plus B line. It goes through this resistor, and I'm hoping that there's some power supply hum that might be generated by weak capacitors over here. So I'm going to replace this guy here and this guy here, and if it works, I will let you know. And here is the THD SNR plot at 1 kilohertz with the amplifier section only putting out 5 watts into 8 ohms, just to compare it to when it's putting out 18 watts into 8 ohms. And you can see that the right channel, the THD plus noise, has improved, as has the THD for both channels. They're both pretty low, less than 0.1%. So it does make a difference as to how hard this amplifier is being driven. Here is the frequency response of the amplifier section only of the KA4002, and this is with it putting out about 5 watts into 8 ohms. And the specification is that from 20 hertz to 40 kilohertz, it should be plus or minus 1.5 dB across the band. And we are meeting that. We're down, we'll say 1.3 dB at the low end of the band. And then over here at the high end of the band, we're maybe 0.2 of a dB. So we are indeed meeting the frequency response requirement of the amplifier section. Here's our THD SNR plot at 1 kilohertz with just the amplifier section after repair. And I have the input signal level adjusted so that we're getting out about 18 watts into 8 ohms, which is the maximum power for this integrated amplifier with both channels driven. It is meeting its requirement of 18 watts into 8 ohms. The THD is 0.05% or 0.1% for the right channel. I did replace the capacitors that I mentioned earlier, and they didn't really have any effect in this. And once I pulled the capacitors, even though they're from 1971, they measured really good. So I wasn't expecting anything, but I went ahead and replaced them, and I'm not going to worry about some of the noise. Now, the other thing to point out is that there is not a specification for the THD. It's rated as intermodulation distortion, which is different than THD distortion. So they didn't really give a THD distortion rating on this, but it does look pretty good overall considering. And you can see we still got a lot of gain in this amplifier section of 42 dB. And even our THD plus noise is right near 60 dB. So that's looking fairly decent. And in case you're wondering about our harmonics, it's kind of a mixed bag here. The right channel harmonic, second harmonic, the even harmonic is higher than the right channel of the odd or third harmonic, but the left channel is how you would typically see it with the third harmonic or odd harmonic greater than the even harmonic. So it's kind of mixed bag on this particular amplifier, on this particular integrated amplifier. Here is our standard THD SNR plot at 1 kilohertz for both the preamp and power amp sections combined as they would be for normal use. In this case, we are putting out 5 watts into 8 ohms, and you can see that our SNRs are both around 73 dB. I adjusted the volume control to give me a gain of around 29 dB. The volume control is pointing near the 6 on the dial. You can see our THDs are 0.2% for the right channel and 0.1% for the left channel. And our THD plus noises are between 56 to 61 dB. So overall, it doesn't look real bad. I did have to adjust the balance control to favor the right channel a little bit. It seems to be performing rather well. Here is the frequency response of the KA4002 with it putting out about 5 watts into 8 ohms. The specification was plus or minus 1.5 dB from 20 hertz to 40 kilohertz. We're only going 20 hertz to 20 kilohertz. And at the 20 kilohertz side, we're down maybe 7/8 of a dB, so we're meeting the requirement there. We're up maybe, looks like 7/10 of a dB over here. And at the low frequency part of the band, we're down right at the limit at 1.5 dB. So it looks like it's meeting its requirement. The channel balance is within about we'll say 1.5 dB. So overall, it is meeting its specification for both the power amplifier and preamplifier combined. Here is a plot of the crosstalk of the KA4002 integrated amplifier, and there really is not a specification for it. It's just kind of for information. You can see both channels are kind of the same. Maybe the right channel is a little bit better. The worst case crosstalk is maybe 30, we'll call it 39 dB right here for the right channel, and for the left channel, it's about 44 dB, we'll call it. And at the low end of the band, they're both right around, say, 43 dB. So overall, the crosstalk is not bad, I guess, for something of this vintage. This plot shows the output impedance of the KA4002. And this would translate to a damping factor of about 27 if you use the impedance is around this area, which is about 0.3 ohms. And the specification was that it should have a damping factor of at least 50. So it's not quite there. Also, it's interesting to note that our low frequency impedance is really high, relatively speaking, to other amplifiers' output impedance. And that probably plays into the low frequency response, or the drop in low frequency response that we saw. Here is the THD SNR plot at 1 kilohertz with the KA4002 putting out 18 watts into 8 ohms. And that is the maximum power it's supposed to put out, or at least that it's spec for, is 18 watts into 8 ohms for both channels driven. It doesn't give any specs on the THD. It does give an IMD that would be less than 0.5%, and I can tell you it's going to be much less than 0.5%. The normal THD is looking pretty good at better than 0.1%, we'll call it. Also, the volume control was still adjusted for about 29 dB a gain. Our SNRs are a bit less than 80 dB, so that's not too bad. This is for the combined amplifier and preamplifier chain together, as it would be for normal operation. I'm going to increase the level of the input signal going into the auxiliary 1 input. That's the input that I've been using so far for these tests. And just see how much more power we can get before our distortion, say, gets above 1% or looking real ugly. So we're at 20 watts, 22 watts, 34 watts. So right there, we'll go down a little bit. So right there, we're not looking too bad at about 32 watts into 8 ohms. We're still less than 0.2%. I probably can go up just a little bit more. And I'm changing my step size a little bit. And right now we're 33.8, 34.6. We're still not looking too bad. And we're still under 0.5% THD. We're still doing okay here at 36. At about 36 watts, we'll call it, we're about 0.4%, 0.23%. So it could go a little bit more than this, but we'll just call it a day there and say that at 36 watts into 8 ohms, it still would be listenable. This plot shows the effect of the KA4002 filters. The thicker blue line kind of going down the center is with the tone controls set to flat and the filters are all off. This red line right here, this curve right here, is the loudness on curve. So when you put on the loudness, it affects the bass maybe up to 300-400 hertz, and then it kind of tapers off. The low pass filter is this guy right here. This is the effect of the low pass filter, and the high pass filter is this purple one, kind of showing what happens when you put on the high pass filter. Here is a plot of the multi-tone response of the KA4002, and it's showing about, we'll just be nice and say 9 bits of distortion-free range. This plot shows the THD versus frequency at a couple of different output power levels, and that's into 8 ohms. The minus 7.4 indicates a power output of 18 watts, and we drop by 3 dB. The minus 10.4 would be about 9 watts into 8 ohms, and so on. So if we ignore this highest power curve right here below about, that's maybe 300 hertz here. So if we kind of ignore that, the THD is below about 0.8% across the band, regardless of the power level. Now at these two high power level, the two 18 watt into 8 ohm levels at above maybe 200 hertz, be right here. So it's getting worse than 1% THD, and that is just what it measured. Here's our THD SNR plot at 1 kilohertz with the KA4002 putting out 5 watts into 4 ohm loads. Now, if you compare this to the 5 watts into 8 ohm loads, you can see that the specs were a little bit better for the case when it ran into the 8 ohm loads. Here we have the frequency response from 20 hertz to 20 kilohertz of the KA4002, with it putting out 5 watts into 4 ohm loads this time. You can see that the frequency response, particularly at the low end, doesn't look as good. It's also a bit worse at the high end compared to the 8 ohm load case. This would be failing the plus or minus 1.5 dB flatness requirement at the low end of the band, basically below about 30 hertz. And at the high end of the band, we're still okay as far as passing that requirement. Here we have the THD SNR plot at 1 kilohertz with the KA4002 putting out about 21 watts into 4 ohms. The rating for the KA4002 was that it could do 21 watts into 4 ohms. And we are definitely doing that. Our THD will say is less than 0.4%. And the SNRs are above 55 dB. The THD plus noise around minus 50 dB, so that's not stellar. It is showing a lot of harmonic action here, and speaking of harmonics, let's see what they look like. It's showing kind of what we saw with the 8 ohm case. We do have the right even harmonic higher than the right odd harmonic, and then we have the left even harmonic lower than the left right harmonic. So it's kind of got mixed results as far as even versus odd harmonics, but that's kind of what they look like. And overall, it looks to me like it performs better with 8 ohm loads. What we are looking at here is the isolation between two inputs. In this case, I have a signal going into the tuner input, and I have the auxiliary one input selected and shorts placed on it. So you're seeing the signal from the tuner input bleeding on over to the auxiliary one input. There is no specification. It's kind of here just for grins and giggles. But I've got a 0 dBV signal going in, so you can read the isolation down here. So it's basically better than 40 dB. Now at 180 hertz and 60 hertz, we do have some of the power supply leakages, but that exceed up to maybe minus 30 dB, I guess, for the case right here for the right channel. But overall, if you kind of ignore those two, you are better than 40 dB across the band, almost 50 dB of isolation in certain spots. There is no specification on this. It's just for grins and giggles. This plot shows the noise level of the KA4002. In this case, our input is the auxiliary one input, and it is terminated into shorts. And we're just looking at the system noise performance, and we are at minus 80 dBV down. There is a specification for hum and noise, they call it, that should be about 70 dB down. So we are meeting that requirement. What we are looking at here is the phono stage. In this case, it's the Phono 1 input. And we are measuring at the tape monitor output. So we're not using the preamp out where you would have tone controls affecting things. It's strictly just the phono stage. And you can see the THD looks real low. I should point out also we've got a 5 millivolt signal or minus 46 dBV signal applied. The gain stage for the phono section is about 36.5 dB. Our SNRs are pretty close to 60 dB. And overall, it does not look that bad. I should point out that I do have the RIA weighting applied. If I were to turn that off, it would add a slope to this plot here. Maybe I'll just do it. So right now I have the weighting applied, and if I go ahead and click that off, you will see kind of this slope to it. So I do like to have the RIA weighting applied, and it definitely will be applied when we look at the frequency response next. Here is a plot of the frequency response of the Phono 1 input to the tape monitor output. And if we ignore this little area here at about 20 hertz or so. It looks pretty good. It's down, worst case, maybe 0.8 of a dB, and at the high end of the band we have maybe a plus 0.4 of a dB. As best I can tell, the frequency response of this section would be plus or minus 1.5 dB. I could not find any specification for the frequency response of the phono section. Now, we do have a little problem right here at 20 hertz. I don't know if this is a measurement error or what's going on with that, but I'll just kind of ignore that. So for the most part, the phono response looks pretty decent. I do have the RIAA weighting applied to it. If I didn't have the weighting applied, we'd have like a slope to it. So this does show the effect of the RIAA weighting. As you saw from the test data, this Kenwood KA4002 integrated amplifier did a reasonable job of meeting its specifications from 1971. Now, it did have a problem with it, and once I solved that problem, was able to test it, it looked pretty good. It didn't require any cleaning of the controls or switches. I think the owner of this unit may have done that at one point, but it worked really, really well. Now, I had mentioned in the repair section of the video that there were a couple capacitors that I was going to look at replacing. I did replace them. It didn't make any difference. When I pulled them, I tested them, and they tested great. They wouldn't have required replacement, but since I had them out and they got short leads, you know, for 50 cents I'll put in another capacitor. But it didn't really need it, and for the most part it worked really well. It has a fair amount of features for an integrated amp. It has a separable preamp and power amp section. It has two phono inputs. They're moving magnet phono inputs, and it has two auxiliary inputs as well as a tuner input, and of course it has a tape monitor circuit as well. So it does have a lot of versatility. It doesn't weigh a lot. It doesn't have a big footprint, and for the right person that's into collecting certain kind of gear, I would highly recommend it. Oh, as far as its sound, I connected it to my typical Wilson Watt 3 Puppy 2 loudspeakers, which are fairly efficient, and this sounded really good. I immediately turned on the loudness switch, so I was getting a boost of the bass, and it did really, really well. The only problem I had with it was when I was playing a fairly bass heavy laden track, which in this case was the Hi-Fi Collective Slow Reduction. It has a lot of low bass in it, and when I was playing that track, I turned the loudness switch off and it sounded fine. But for most of my listening, I had the loudness on to get that little bass boost up. I thought this sounded really good. It didn't lack anything. I was able to hit a 90 dB SPL at points during my listening, which is pretty loud in that room. You're obviously not going to want to use this to DJ a party with or drive a real inefficient loudspeaker, but for a lot of uses this would be a great little integrated amp with a lot of versatility, and you know, it is a vintage piece of gear. So if you're able to find one and it seems to work and you can get it for a good price, I would recommend it. Prior to the start of my listening tests, I connected shorts to the auxiliary 1 inputs, and with the volume control set to give me 29 dB of gain, which is where it was for all the testing, I was able to hear a bit of hiss coming out of both speakers, which is quite normal. There was a little bit of hum, a little bit of hiss, probably a little bit louder on the hiss, but it kind of went away when you were maybe 3 to 4 foot away. It's really quite normal to have hum and hiss on vintage amplifiers. And it was not objectionable. As far as turn off or turn on thumps, there were none. And overall, the amplifier just did a pretty good job. Once again, if you liked the video, hit the thumbs up. If you have comments, I always like to hear them so far, and I will respond back to you. And if you have not subscribed to the channel, please do so, as it helps the channel grow. So, until next time, have a great day or night.